Welcome to Blueprint to Reality. Today, we're covering a crucial topic in structural engineering, assessing structural risks and implementing mitigation strategies. Every structure, from high-rise buildings to bridges, faces potential risks, and it's up to engineers to identify these risks and create plans to address them. But how do engineers assess structural risks, and what strategies do they use to mitigate them? Let's break it down. Understanding structural risks. Structural risks are any factors that could compromise the integrity and safety of a building or infrastructure. These risks can include natural forces like earthquakes, hurricanes, and floods, or human-related factors like poor design, material degradation, and unexpected loads. Engineers conduct a thorough risk assessment to identify potential vulnerabilities in a structure, which often includes examining the location, design, materials, and intended use. By understanding the unique risks a structure might face, engineers can plan accordingly to create safe, resilient designs. Risk assessment techniques. Risk assessment involves both theoretical and practical approaches. Engineers use simulations and modeling to predict how a structure will respond to various forces, like wind loads or seismic activity. Historical data on local weather patterns and past incidents are also analyzed to anticipate potential threats. Additionally, on-site inspections and materials testing reveal the existing condition of older structures, identifying weak points that may need reinforcement. These assessment techniques help engineers gain a complete picture of potential risks, forming a foundation for targeted mitigation strategies. Common mitigation strategies. Once risks are assessed, engineers can implement strategies to strengthen a structure. For earthquake-prone areas, they might use base isolators that absorb seismic shocks, allowing the structure to remain stable. For regions with heavy winds, aerodynamic designs or dampers are employed to control swaying in tall buildings. Flood defenses, like elevated foundations and water-resistant materials, protect against water damage. Redundancy is also critical. Adding backup support systems ensures that if one part fails, the structure can still stand. These mitigation strategies help manage risks, keeping structures secure even under extreme conditions. Ongoing monitoring and maintenance. Risk assessment and mitigation don't stop after construction. Engineers incorporate monitoring systems like sensors that track structural health in real time, providing data on stress levels, vibrations, and movement. Regular maintenance is essential as well. Inspections, repairs, and material replacements address wear and tear before it leads to failure. This proactive approach ensures that structures stay safe and can be adjusted over time as new risks or environmental changes emerge. Monitoring and maintenance are vital components of a resilient structure, ensuring long-term safety. The path to safe, resilient structures. Assessing structural risks and implementing effective mitigation strategies are essential in the field of structural engineering. Through careful risk assessment, targeted design choices, and continuous monitoring, engineers create buildings and infrastructure that can withstand the unexpected. These processes make our built environment safer, more resilient, and ready to face whatever challenges come its way. Thanks for watching Blueprint to Reality. If you're fascinated by the techniques that keep our structures standing strong, make sure to subscribe for more insights. Join us next time as we explore more engineering marvels and the science behind them. See you then. Welcome to Blueprint to Reality. Today, we're looking at one of the most exciting fields in architecture and engineering, the future of sustainable skyscrapers. Skyscrapers have shaped the identity of our cities, but their impact on the environment is profound. As urban populations rise and climate challenges mount, the race is on to build taller, greener, and more efficient structures. So, what could the future of sustainable skyscrapers look like? The shift toward sustainability. Skyscrapers have always been symbols of progress, yet many are major energy consumers. Typical tall buildings use vast amounts of resources in construction and upkeep, often relying on energy-intensive materials and systems. But with a shift toward sustainability, new designs prioritize reducing energy consumption, carbon emissions, and resource depletion. Cities around the globe are investing in green architecture, demanding that tomorrow's skyscrapers align with our urgent environmental goals. In the future, sustainable skyscrapers won't be the exception. They'll be the standard. Green building materials. Traditional concrete and steel are massive carbon emitters. New materials like cross-laminated timber, eco-concrete, and high-performance glass are paving the way for sustainable skyscrapers. A cross-laminated timber, for example, is not only renewable but also absorbs carbon, reducing overall emissions. Eco-concrete, meanwhile, can absorb pollutants from the air, literally cleaning our urban spaces. High-performance glass allows for natural light while minimizing heat gain, reducing the need for artificial lighting and air conditioning. The future of sustainable skyscrapers will depend on materials that do more than hold up the building. They'll help heal the planet. Innovative energy solutions. Imagine a skyscraper that produces more energy than it uses. Cutting-edge designs now feature energy-generating facades with integrated solar panels, wind turbines, and rainwater harvesting systems. Some buildings use smart technology to regulate energy use in real time, adjusting heating, cooling, and lighting based on occupancy and weather conditions. With these innovations, future skyscrapers could operate as self-sustaining ecosystems, generating clean energy, conserving water, and significantly reducing their carbon footprint. Vertical gardens and urban agriculture. The integration of nature into skyscraper design is a powerful trend. We're now seeing green walls and vertical gardens on skyscraper exteriors, reducing heat absorption and creating natural air filters. Imagine buildings with entire floors dedicated to urban agriculture, growing food for local communities. These green spaces not only make cities more beautiful and livable, but also combat air pollution and provide a home for urban wildlife. In the future, skyscrapers might serve as mini forests and farms, creating a new synergy between nature and architecture. The skyscrapers of tomorrow are more than just tall buildings. They're sustainable ecosystems, designed to blend seamlessly with our cities and the natural world. Engineers and architects are rethinking every aspect from the ground up to make structures that reduce our environmental impact and inspire a more sustainable future. As we look to the sky, we're reminded that the way we build today shapes the world we'll live in tomorrow. Sustainable skyscrapers are the future of urban design, and they're set to redefine our cities and our planet. Thank you for tuning in to Blueprint to Reality. If you're excited about the future of sustainable architecture, don't forget to subscribe and join us next time as we explore more innovations in engineering. See you then. Welcome to Blueprint to Reality. Today, we're diving into a topic that's reshaping the world of engineering, sustainability in structural design. As our planet faces growing environmental challenges, engineers are being called on to design structures that minimize environmental impact and prioritize long-term resilience. But what does it mean to build sustainably, and why is it so crucial in structural design? Let's break it down. Understanding sustainable structural design. Sustainable structural design is about creating buildings and infrastructure that meet today's needs without compromising the ability of future generations to meet theirs. This means using resources efficiently, reducing emissions, and ensuring that structures are resilient against future environmental challenges. Engineers focus on choosing materials, methods, and designs that are both durable and environmentally friendly. Sustainable design isn't just a trend. It's becoming a core principle of responsible engineering, ensuring our built environment works in harmony with the natural world. Choosing eco-friendly materials. One of the biggest ways structural engineers can impact sustainability is through material selection. Traditional materials like concrete and steel are effective, but they come with high carbon costs. To address this, engineers are now using alternatives like recycled steel, eco-concrete, and cross-laminated timber, which are either renewable or have lower emissions. Cross-laminated timber, for example, is a renewable resource that also captures and stores carbon. By choosing these eco-friendly materials, engineers reduce the carbon footprint of new structures and contribute to a more sustainable construction industry. Designing for energy efficiency. Energy efficiency is another key aspect of sustainable design. Buildings consume a significant portion of the world's energy, so designing structures that use less energy is essential. Engineers incorporate strategies like natural ventilation, high-performance insulation, and strategically placed windows that bring in natural light while minimizing heat loss. Some designs even integrate renewable energy sources like solar panels and wind turbines directly into the building structure. With these strategies, sustainable structures reduce their reliance on external energy sources, cutting both costs and environmental impact over the building's lifetime. Resilience and durability for the long term. Sustainability isn't just about environmental impact, it's also about resilience. Engineers design structures that can withstand natural forces like earthquakes, floods, and strong winds, ensuring they last longer and require fewer repairs. Using modular designs or materials that can be easily repaired or replaced also extends the life of buildings, reducing the need for new resources. By building for the long term, engineers create structures that not only serve communities but also conserve resources and reduce waste. Building a greener future. Sustainability in structural design is essential to protecting our planet and creating a resilient future. Through careful material choices, energy-efficient designs, and long-lasting structures, engineers are transforming how we build, ensuring that our structures are part of a sustainable world. As we continue to face environmental challenges, sustainable structural design will be key to creating cities that thrive in harmony with nature. Thanks for watching Blueprint to Reality. If you're excited about the future of sustainable engineering, make sure to subscribe. Join us next time as we explore more groundbreaking innovations in the world of construction and design.
See you then.
Welcome to Blueprint to Reality. Earthquakes are some of nature's most powerful forces, capable of shaking entire cities to their foundations. But thanks to advances in earthquake engineering, we can design structures that stay standing, even in the face of extreme seismic forces. Today, we'll break down the key principles of earthquake engineering and see how engineers design buildings to withstand the forces of an earthquake. Let's dive in. Understanding seismic forces. First, it's essential to understand how an earthquake affects buildings. When an earthquake hits, it sends seismic waves through the ground, causing rapid shifts that move buildings from side to side, and sometimes up and down. These seismic forces create intense stresses, which can cause walls to crack, beams to bend, or even entire buildings to collapse. Earthquake engineering begins by understanding these forces and predicting how they might impact different structures. Engineers study past earthquakes and use this knowledge to estimate how strong, frequent, and sudden these forces could be. Designing for flexibility and strength. One of the primary goals in earthquake engineering is to design structures that are both strong and flexible. If a building is too rigid, it might break under the shifting forces of an earthquake. So, engineers use materials like reinforced steel and flexible connections that allow parts of a building to move without snapping. Skyscrapers, for example, are designed with a certain degree of flexibility to sway rather than break during a quake. This combination of strength and flexibility helps buildings absorb and dissipate energy, reducing the risk of severe damage. Base isolation systems. A major innovation in earthquake engineering is the base isolation system. Base isolators act as shock absorbers, placed between a building and its foundation. During an earthquake, the isolators allow the ground to move beneath the structure, while the building itself stays relatively stable. This system reduces the forces transferred to the building, protecting it from the brunt of seismic shocks. Many modern hospitals and emergency centers use base isolation to stay operational during and after an earthquake, ensuring that essential services remain available. Dampers and advanced seismic technology. Dampers are another critical tool in earthquake-resistant design. Think of dampers as giant shock absorbers that slow down the movement of a building during an earthquake. By absorbing kinetic energy, dampers reduce how much a building shakes. Engineers also use cutting-edge technology like real-time monitoring systems that alert building operators when an earthquake is happening, allowing them to shut down elevators or turn off gas lines automatically. These systems, along with dampers, help reduce damage and keep occupants safe. Building resilience for the future. Earthquake engineering has come a long way, transforming how we build and protect our cities. Through a deep understanding of seismic forces, designs that balance flexibility with strength, Innovative systems like base isolators and dampers and advanced monitoring technologies, engineers are making our world more resilient to earthquakes. With continued advancements, we can build a future where even the most powerful earthquakes have a smaller impact on our lives. Thanks for joining us on Blueprint to Reality. If you're fascinated by how engineers shape our world to stand strong, make sure to subscribe for more insights. Stay safe, and we'll see you next time.